All right, so, and this is something that, is going to come up over and over in this class, but I just want to talk about it now. So comparisons with math. Oops. And most of, lesson 4 was mostly about these kinds of comparisons. It came up a little bit in lesson 5. It's going to come up again in lesson 6 and on and on. So, for example, Jenna just fell into a little money. She just ended up with $70, right? And Robert, he ran into some too, but not quite as much. He ended up with $20. So things we can say, like we can say Jenna has more money than Robert, right? But that's not a very descriptive statement. I wouldn't even call it a quantitative statement because it's got no quantities in it, right? Just more than isn't enough. I could just say Jenna has 70 and Robert has 20, right? That's a direct comparison, but it doesn't talk about the difference between them. So there's 2 ways to talk about the difference between them. One way is to just actually use a literal difference, which is kind of the most common way. And it's just difference means subtract, right? So I take Jenna's 70, I subtract Robert's 20, I get a difference of 50. So then could I say Jenna has $50 more than Robert? Okay. So is that a lot more or is that a little more? Or does it depend? Yeah, it kind of depends, right? So if Jenna had $1 million and she had $50 more than Robert, does she have a lot more than Robert? No, you can't even tell the difference, right? But here, Jenna has 70 and Robert has 20, so 50 feels like a lot more. Okay? So just finding the difference isn't necessarily a meaningful thing, but it does mean something, right? So the other thing we can do to talk about the difference of values is to talk about their ratio. Right. So I can try to find the ratio of Jenna to Robert. And generally, the way we speak the ratio is the same way that we calculate it. So if I say Jenna to Robert, the ratio is literally Jenna divided by Robert. Okay, so in this case, that would be the 70 divided by the 50, or 20, sorry. There we go. And I could reduce that a little bit. So just whip out a calculator and tell me what 70 divided by 20 is. Okay, 3.5. So that's 3.5 or 3.5. Now, there's another division. Actually, there's a whole bunch of other divisions I could have done. I could have done Robert divided by Jenna. I also could have done the difference divided by either one of them. Okay? Like Robert's sitting there thinking, hey, man, that's not fair. She got more money than me. I want a raise. What kind of raise would I have to give him? When we talk about things like raises, that's looking at the difference divided by one of the other things, right? Did we do the difference divided by something here? No, we did a direct ratio of 2 numbers. So here's what I'd like you to do. Write me a sentence explaining what this 3.5 means. And just a warning, don't worry about writing a wrong sentence. Just write a sentence. My belief is 8 out of 10 people will get this wrong. No big deal. We just want to try and correct it now. What's that?
Where are we putting it?
This is just stuff, notes.
Oh,
putting
okay.
notes. Yeah, it's not directly on one of the projects. But this is something that's going to come up over and over and over again. These kinds of comparisons. Not to put pressure on you, but I feel like the most important thing in the course all quarter. It's a big deal. Sort of. What does that 3.5 mean? So write a sentence. Sentence has to have at least one number in it, preferably more. Welcome, Jose. So it looks like most people wrote something down or just finishing. Just really quick here. If I were Robert, I'd be thinking, man, I want $50 more. That would make it fair. What's 50 divided by 20? 2.5? Okay, so that is a relevant number to this problem too, and I'll use that one in a sentence in a second too. So here's the way I would put the sentence. Like maybe to my mom who doesn't have all the background. So I could say Jenna's $70 is 3.5 times Robert's $20. Does anybody think they have a similar sentence to mine? Pretty darn similar. Okay, so I'm gonna pick on somebody, let's pick on Emily. Can you read me your sentence?
Jenna has 3.5 more than Robert's 20.
Just 3.5 more? You didn't use the word times?
No.
Okay.
Going to, but then it's like.
Yeah. So she did it a little bit different, but that's supposed to say times, plural. So what happens if I take 3.5 and multiply it by the 70? Whip out a calculator, check. Oh, sorry, no. 3.5 times Robert's 20. There we go. I get exactly 70, right? So this is a literal mathematical equation I put into language that my mom would appreciate more. Okay. How much more does Jenna have? $50 more. So if I want to talk about, notice I didn't use the word more in here. If I want to talk about how many times more Jenna has, that's where the 50 comes into play. 50 over 20 is 2.5. So if I want to use the 2.5, that's when I would go times more, because it relates to the amount more. Okay. So the $50 is the difference. That's how much more. If I divide that by Robert's amount, instead of dividing 70 by 20, if I go 50 by 20, that's times more. So and I say this wrong all the time too. I throw the word in more when I really don't mean it. More is the raise, right? Does Robert deserve a raise of 3.5 times the 20? That would be a $70 raise. How much should his raise really be? 50, which is really 2.5 times more than the 20, right? So when we use the word more, that relates to the raise. That's the amount difference. If it's just, we divided two numbers and we're comparing them, it's just this number is times that number. We don't use the word more or the word less, okay? Which takes some getting used to. I mess it up on a regular basis. I'm sure I do it at least once a week. So just a note, if you did want to use the word more, I would have to make a note that if I take 50 over 20, that comes out to 2.5. Remember, 50 is the amount more. So then I could say something like Jenna's $70 is 2.5 times more than Robert's $20. Okay, so that's the accurate way of using those two ratios. So is it good to find the difference? Answer is yes. Is the difference always meaningful? Answer is no. It depends on what the original numbers were. 50 out of 70 is a big deal. 50 out of 1,000,000 is not a big deal. And then when we do a comparison with a ratio, we can either compare the original amounts, and then we just use the word times. We do not use the words more or less. Otherwise, it's kind of misleading. If we want to use times more than or times less than, then we have to use the difference divided by some number to talk about it. And it takes getting used to. Again, it's a common screw up. I bet if I pull out a newspaper every day, I will find somebody screwed this up in the news, a journalist that does this kind of stuff every day. It's a common misuse of language related to how numbers are calculated. So the reason I mention this is just when I was grading the 1.4, people sometimes wrote this stuff right, but sometimes didn't. And so I just, in general, I don't think it was clear yet. All right, so I didn't quite finish the 1.4s. I'm 3/4 of the way through them. They required a little more comment than the last one. That's not a bad thing. You guys still did great. That's just, I have to write a little more. All right, so are there any questions on 1.5? Because I would like that turned in today. Okay, we got a couple questions here. What do you got? Start with Emily.
I really went over it yesterday, but I didn't get all the number 6.
Okay, let's take a look at number 6. Did anyone find the special thing I posted yet? I posted my answers. I would highly recommend, because this was a tough one, I thought, in terms of just sheer calculation. So I would recommend looking at my work to see how I wrote stuff down. Yeah. So I'm going to bring up my answers. So here's a link to my work. So I just scanned it, plugged it in, so you can see how I wrote things down. And then not all of my work is shown. So I have a link here to a spreadsheet I plugged some numbers into. You can take a look at that too if you want. It's optional. I just recommend looking at it. All right, so let's see, where are we? Number 6, you said. Where the heck is 6? Right there. Can I pop this into a new window? There it goes. All right, blow you up. And number 6, okay. So my work is, some of my answers here, but not my work. So that's on my spreadsheet. I'll show that in a second. So a typical texting response time, this is the one you wanted to talk about?
Yeah.
Okay, is 2 to 6 seconds. And the car is traveling at 35 miles per hour. So I have to look back at my calculation for 35 miles per hour, which I think was on a previous page here. Where's 35 miles per hour? Okay. So I guessed it went about 200 feet. When I did the calculation here, I got about 205 feet. Does that match what you guys calculated? Okay. So but the more important one is I calculated about 51 feet per second. And the first run through there. So then I can use that value right there to finish this one off right here. All right. So I've got the car would travel between 100 and 300 feet at 35 miles per hour. And then I stated it using inequality symbols. So the distance it travels is going to be greater than 102 and less than 308 is what I calculated. And that was based on my answer to number, I think it was 3 there on the previous page.
How you got.
Yeah.
They had to do math.
You thought I had to do more math?
Yeah.
I did, but I already did the math, really, because it was on the previous page. All I had to do is look back at the calculations I made for 35. So like in my spreadsheet, I'll just bring that up for fun here. Number 6, I just took the calculation I made for number 3, the 51 1/3, and the formula says just multiply that by 2 seconds. And then my formula over here, guess what it does? It just multiplies by 6, yeah. So I just had it look back at that number on the screen there to do the calculation. So those are both there if you want to take a peek at how I did my stuff. Okay, next question. Jenna, you had one.
I'm having trouble with
10, okay. I think that was the one I was hoping somebody would ask about. Yes, 10 was a wicked one. So I'm going to rewrite all my work for that. So again, you guys can look that one up. It's on the website. My work for 10, where is it? Over here. Okay, so there's an easy way to do it, and there's a hard way to do it. Yeah, and I'm not too worried about the second one, but it is a big deal. So I'm going to draw a picture about why I got to do it this way, and then I'll actually calculate it. So bring my paper out. So number 10. All right. So converting linear measurements, that's no big deal, right? It's usually just a single fraction, like converting feet to inches or whatever. Converting things like area and volume, those are a total pain in the ass and here, in the butt, sorry. Here's the way to think about that. Let's just talk about feet and yards because that's an easy one for me to draw. How many feet are in a yard? 3. Yeah. There's 3 feet in the yard. So let's suppose I draw a square yard. Okay, so this is 1 yard by yard. There we go. By 1 yard. So although converting from yards to feet is just multiply or divide by 3 depending on the direction, if I'm converting from square feet to square yards, that's a little bit different because there are 3 feet in each yard in each direction. And so if I draw all of that out, how many square feet are in a square yard? 3 times 3 is 9, yeah. So although 1 yard abbreviation, not a lame abbreviation, we just dropped the A. That always pissed me off. Anyway, is equal to 3 feet. If I try to jump dimensions from straight line to area, I basically have to square both sides of this equation. And so that gives me 1 square yard, which sometimes we'll write as yard squared, right? It means the same thing, would actually be 9 square feet. Or if you like this notation, whichever you prefer. Now it gets even more exciting when we throw that into 3 dimensions and we start talking about volume, right? So in construction work I've done in my past life, I'd often have to go get like fill for a lot we were working on, a bunch of gravel, whatever, and they sell that stuff, they call it yards, but it's really cubic yards, right? So how much is like 10 cubic yards? That's a hard thing to picture. So just a note, I'm going to attempt to go 3D on you here. So help me out. Someday we will have, did I already talk about this? That we'll have 3D boards and I can like hand you like an Iron Man or.
I think they have like a 3D thing.
They do have those now, but I think you guys would all need like special glasses or. All right. So here is a cubic yard. So that's 1 yard by 1 yard by 1 yard. If I break it into feet, that means I have to take the width here and break it into feet. I have to break the length into feet, and I have to break the height into feet. Okay, and so when I do that, I'm going to get this grid of cubic feet, right? All right, here's where it gets more challenging. That's not too bad, huh? Looks like a Rubik's Cube, right? So how many of these little cubes here live in the cubic yard? Kristen, what you got?
Yeah.
Oh, man. Alicia? Jenna? Robert? Cole? How many of the little square cubic feet are in the cubic yard?
54.
Not 54. Not 60.
I was thinking 90.
No.
There's 9.
Wait,
27.
27, yeah, because isn't this 3 feet by 3 feet by 3 feet?
Yeah, it's 9 times 3.
Or 9 times 3, because there's 9 in the bottom. So 9 times 3 is there are 27 cubic feet.
That's why, because then I was like, oh
The
yeah.
flat things?
Six.
Oh no, we're going 3D here. So there's a little 3D cube sitting here at the bottom. See it in there? Okay, cubic feet. All right, so now we've clarified the question. There are, you all with me now? There are 27 cubic feet in 1 cubic yard. Yard cube. All right, so then we get more exciting. Like think about, what's it going? Where's my meter stick? Oh, you guys can't see my meter stick over there. So I have a meter stick. Oh, there it is. And a meter stick also has centimeter measurements. Does anybody remember about how many centimeters are in a meter? 100. Excellent. Good guess. So there's 100. So if I want to talk about a cubic meter, how many cubic centimeters are in a cubic meter? The way to do that is, well, I know that there are 100 centimeters in 1 meter. If I want to jump into 3 dimensions, guess what I got to do? I got to cube everything. So that means I got to cube this sucker, and I got to cube that sucker. So that means I got to take 100 times 100 times 100. which is a 1 with 1, 2, 3, 4, and then 5, 6, right? 2 has to come, 2 zeros have to appear 3 times. That's a lot, huh? What is that? A million? Did I get that right? There are a million little tiny cubic centimeters. Centimeters cubed. Sometimes it's written as cc's in 1 cubic meter. It's a lot. Okay. So now that we get that out of the way, we're going to convert number 10. Where's my paper? There it is. Okay. So I calculated, what did I calculate? The area of this floor in meters was 54.16 meters squared. Anybody got a similar number there? About 54? Okay.
So we wanted to round it to like with just one decimal.
54.2, that's fine.
I just accepted 54.1596.
Yeah, so I didn't say where to round, so you pick where you want. The main reason I went to 2 decimal places, we talked about significant figures last week or the week before. Where's my sheet? When we measured the room, the tape measures we used had centimeters on them. Centimeters is 2 decimal places on a meter. So I was confident that these measurements in 8A and B were accurate to 2 decimal places. So therefore, any calculations I make on them are still accurate to 2 decimal places. So I thought it was safe to stick rounding to 2 decimal places. Okay. Yeah. So I had 3 significant figures there. 2 decimal places is what I was working with. Somebody else might argue that you should really call it 54.2 because you only have 3 non-zero digits here. So there's a couple of ways to think about it. All right, so number 10. Oops, did I go past it? Yep, there it is. Okay, so I'm going to go over how I came about this calculation right here. And so let's do it. So I'm starting with 54 point, I'm going to call it 16, and that was meters squared for the area of the floor. And I was asked to convert this into square feet. Now, if I'm using that cheat sheet that was given in this exercise here, then the only link I have between the metric world and the American world here is that there, in 1 inch, there's 2.54 centimeters, which meant I had to convert meters to centimeters so I could use their fact to convert centimeters to inches and then convert inches to feet. Man, that was a pain in the butt. Okay, so I'm going to do it a slightly different way and see if I get a similar number. I'm just going to go to Google and I'm just going to ask how many feet are in a meter, because Google will tell me that. I think it's about 3.28, yeah, so let's double check, but I think Robert's right. Feet to meters, let's go the other way. In 1 meter, there's 3.28, yeah. And that's a linear conversion, not an area conversion. To do the area conversion, I have to square everything. So I'm just going to make a little note down on the bottom of my page so I can use it. 3.28 feet is about equal to 1 meter, but really I want those numbers squared so I can talk about area. So then I whip out my calculator and I take 3.28 times itself times 3.28, and Google says it's 10.76. Let's go with that, 10.76. So now I just found that there are about 10.76 square feet. Oops, that's not my pen. In 1 square meter. 1 meter squared. So I can use that as my conversion fraction to get rid of meters squared. It goes in the bottom, to get feet squared in the top. And let's see, that means the 10.76 has to go in the top, and the 1 goes in the bottom. So I just multiply by 10.76 and see what happens, right? Because that's going to allow me to cancel the meters. Calculator, 10.76 times 54.16, is that what we're using? And I get 582.76, 582.76. 582.76, what are the units of that measure? feet squared or square feet, whatever you want to call it. But it's definitely not just feet. So that's what I came up with. When I did it earlier, since I used a different set of conversion factors, I got a slightly different answer. What did I get? I got, oh, where'd it go? Oh, I popped it into a new window, didn't I? There it is. I called it 583. Okay. So bottom line is usually when you look up conversion factors, they're about linear measurements. If you need to convert to area or volume, you have to square or cube those to use them, which kind of makes it look crazier. So alternatively, before you start multiplying stuff, just convert to the unit you want. So earlier here, I was asked to do something like convert the length of the room into feet. So I just converted the width into feet too, and then I just multiplied. That was slightly easier. I just take the feet measures and multiply them. I get almost the same number. Okay. There's going to be rounding error because I rounded at different times when I did those. So does part B look easier than part A? It is and it isn't. It was just as much work. I just did it in 3 stages. What were the 3 stages? The 3 stages were I had to take this number right here and convert it to feet. Then I had to take this number right here and convert it to feet, and then I could multiply them. And so this looks easier because I didn't show that work there. I did it off to the side. Or I could do it all in one shot right there. But you got to keep in mind, when you're playing with area or volume, you got to double check that you're using the right conversion factor. So if you haven't already, I would like you to take a look at the next part, which basically, yeah, does the same thing, but with volume. So based on the feet, find the volume in cubic feet. So based on the measurements we took in class of this room, I thought it was about 23.8 feet. I remember somebody telling me that. I think it was Aaron. And then somebody told me it was 24.5 wide. And then I remember Tristan said it was 9 feet tall. So I just multiplied those 3 numbers together, and I got about 5,247, 5,248 cubic feet. Okay, so depending on how we use the numbers, we're going to get slightly different answers, but we should all be in the ballpark. You should all have 5,200 and something if you're in the ballpark. So we were asked to do it in cubic feet up here. Yeah. Now, in question 12, we originally were asked to measure the length and width in meters. And then right after that, we were asked to convert the height to meters. So I already had those numbers converted. So it was just a matter of multiplying them together. So I got about 146.2 cubic meters. So if you could double check, you get a similar number for 12A. And then I'll do 12B over again.
Could you go back to 10 when you were writing when you get a chance?
Yep. I can just show it to you here. 10. So I'm going to go over how I got B in just a second. You guys are going to help me do it. Okay, so let's do number 12B together. 52479. So we're gonna need that cheat sheet. So 5,247.9, and that was cubic feet. And I want to convert that to cubic meters with some conversion factors. So the book gives the centimeters to inches conversion factor. So I want to first convert feet to inches. How many feet are an inch? 12. So what would I do to the 12 to talk about cubic feet and cubic inches? I would cube it, right? So if I want to change that measurement right there from feet cubed to inches cubed, since I know there's 12 inches in a foot, then that means I'm going to have a 12 cubed here as my conversion factor. I don't even care what 12 cubed is. 12 cubed is a number I can use it. I don't have to multiply it all out. And there's 1 in the bottom. So that gets me that conversion. So I'm going to do this similar but slightly different to what I wrote on my paper. All right, so I have it in cubic inches. Now I can use the conversion fraction that the worksheet gave me, which is how many centimeters are in an inch? 2.5-ish. They said 2.54, I think it was. So I want to get rid of inches. So I'm going to have an inches cubed. I'm going to change it to centimeters cubed. Now the 2.54 is a linear measurement. I have to use that 3 times. So that means for every 1 inch, I'm going to have 2.54 cubed centimeters. Okay. And that will allow me to get rid of inches cubed. I'm almost where I want to be. I need a little more room. Can't wait. Soon we'll have paper that you can do this on. I shrink that, give myself a little room. Isn't that cute? All right, so now I'm at cubic centimeters. What do I want really? I want cubic meters, right? So then we need to multiply by another factor where we get rid of centimeters cubed and change it to meters cubed. So what do you know about centimeters and meters? There's 100 centimeters in a meter, right? So that means for every 1 cubic meter, I'm going to have 100 cubed centimeters. All right, so here's the challenging part. Can you type that into a calculator? Give it a try. Let's see if we get an answer that's roughly the same. You can do it. Give it a try. Everyone try this on your calculator. Yeah, so you're going to take your 5,247.9 and multiply it by 12 to the 3rd power. Then you're going to multiply it by 2.5 to the 3rd power. And then you're going to divide it by 100 to the 3rd power. Okay. And I think we're going to get an answer, what, in like somewhere near 150? Is that what I had before? That's somewhere there. Lost it. There's somewhere in my pile. All right, so I'm going to whip out my calculator. There's my calculator. I'm going to try my Google calculator. All right, clear. 2547.9 times 12 cubed times 2.54 cubed. And some calculators are easier to plug this into than others. Like I would be cursing if I had my Apple calculator right now. Divided by, what's the last one, 100 cubed?
Isn't it like 5,
4 or something.
2, 4, 7
5, 2
at the
something.
beginning?
Oh, I got those backwards?
Yeah.
Ah, and I can't edit it. I got to start over. Darn. Yeah. Okay, 5247. I got it right this time? 0.9?
Yes.
Okay. Times 12 raised to the 3rd. And you could do this one step at a time, hitting equals all each time, or on some calculators you can do it all at once. But you need to be the master of your calculator, whatever it is. If your calculator pisses you off too much, then find a new one. Let me know if you need help finding a new one. Divided by 100 raised to the 3rd power, and I get about 148.6. Is that what I got before? You know what?
I have a backpack.
Which one do you have?
I have an apple.
Oh gosh, put that sucker away. That's useless. Yeah, the Apple calculator is too painful to type in here. So actually, if you have a browser, you could do it straight from your browser, but